Okay, the next part we are going to discuss on the typecasting. Okay, we are going to discuss something called as a typecast or a typecasting. So let me make it as a typecast. So what basically typecast is? First, I will demonstrate you the program. Okay, we had already seen this program. Okay, in one of the this particular behavior in one of the program. Let me repeat those things over here. Okay, now I hope I am audible to you. Are there any audio problems at you?
Audible,
So
sir.
there are some audio problems, sir.
You are facing audio problem. Probably it is like it is happening to you only, miss, because all others are finding it's they are not finding any difficulties. So you need to check with your device, okay, or the network area where you are sitting. Okay, you need to just check it out because all others are absolutely having no problems. Okay. Okay, fine. Now typecasting we are going to discuss over here. Okay, now for that, let me take a very simple example. Float, I'm taking one variable float, say div, division. Okay, then now what I will do, I will store this value, say 5 divided by 4. And what I'm doing here in this line number 8, 5 divided by 4, that is a arithmetic operation, division operation. So 5 divided by 4 will be calculated and will be stored where? It will be stored into a div variable. Okay, so in order to just show you the tracing in the sense how the program execution works. Okay, now we have one variable called as div. So what in div, what are we doing? 5 divided by 4. So tell me, what is the value 5 divided by 4? How much we get? Mathematically, you tell me. If you divide 5,
1.25.
1.25, right? We get 1.25. It is getting rounded off over here. 1.25. Okay, now, so when I declare this line division float equal to division means in the memory block there will be a division. Okay, one particular memory block will be there, and in that one the next line is what? 5 divided by 4 operation will be performed, and that result will get updated in the division over here. Okay, now if I print the value, now here, see here, print f double quote division equal to, since the format access format we need to use here, what is the variable, what is the data type? It is a float, so I will use it to be percentage f, then slash n double quote complete comma, then name of the variable division. Okay, that's it. So very simple statement I have taken. Declare a variable first, okay, and calculate 5 divided by 4 and then store it into that variable, then print that value over here. Okay, now let us go to the terminal and compile the program. GCC to compile followed by name of the program. So name of the program here it is typecast.c. Okay, and press enter. Okay. Yes. Okay. So let me quickly give a recap of that, what we were discussing. Okay, so we had declared a variable of a float data type and we are performing a division operation. Okay, and we were displaying the result, that is division operation, whatever the result is there, that the result we were displaying on the screen. Okay, now when we compile and do the division, this is the answer we had got here. Division is equals to 1.0000. Okay, but when we had calculated it manually, what was the answer we got? 1.25. But why this was happening here? Why we were not getting 1.25, but why the result is 1.0 only? But when you look at the program, the division, okay, is a float only. Float means what? It can store the fractional parts as well, but it is not storing that 0.25 in its variable. So what is the problem here? Okay, and I had told you one of the quick solution for this in the previous program, that what we were doing there. Does anybody remember?
Adding float before the 5.
Adding float before the 5. So we were trying to do one thing, that is we were adding float within the bracket, okay, before this one first number, that is 5 over here. When we had done that one, okay, I just saved the program and we compile the program and then execute. This time we are getting the correct answer as 1.25, isn't it? So what was the change happened over here? Why when we added this float, okay, how come we were getting the 1.25 as the result, but when we had made it as a just 5 divided by 4, why was not result coming up? Okay, this is something we need to understand. Okay, am I audible properly? I got a message here that internet is unstable. Are you able to hear me?
Yes, sir, no problem.
Okay. Okay.
Yes, sir. No problem, sir.
Okay, fine. Now, pay attention here. Try to understand this concept. Now, this is what? One statement. In this statement, how many operators are there? There is one equals to, there is division. If you remember that previous class where we had seen the priorities, right? Division is what has got the lower priority, sorry, the equals to, that is assignment has got lower priority than the division. So first division will be performed. So in the division, if you look at here, 5 we have and 4 we have. Now tell me, this 5, what type of data type is it? Is this 5, okay, I will just comment here. Is this 5 is integer or float? That is first question. What is this 5 is?
Integer, sir.
It is a integer, right? How can we say it is an integer? Because if you look at here 5, it is a whole number. We do not have any point. We do not have anything like this, right? 5.07 or anything. It is just a 5 integer number, right? So that we got the answer for first one. Then second is the second number 4. Okay. Now, if you look at this 4 also, what type of data type it is? Again, it is an integer number. Yes or no?
Yes, sir.
Okay. Now look at the screen here. When I perform integer divided by integer, okay, see here, I'm performing what? Integer divided by integer. That means I'm dividing an integer number by another integer number, then result whatever I get, okay, that values data type is going to be what? It is going to be an integer only. Okay, when I divide an integer by another integer, both are same data type, and when I'm performing this one, I get a result, that value, and that value's data type is going to be integer only. Even though it produces a fractional number, but it is going to store, it is going to work upon only integer values. Okay, understood this one?
Yes, sir.
Yes,
Now,
sir.
so what has happened here? 5 divided by 4 we performed. Okay, we know that when we perform 5 divided by 4, we get the value as 1.25. Okay, we know as a human being, we know this thing. Okay, but for computers try to understand in this way. 5 is, there are two numbers I need to perform a division. First number is what? Integer value. Second number is what? Integer value. Okay, now it is being told to the compiler or the computer here is that when you perform integer divided by integer, you have to take the result in form of integer only. So now here, if you look at here 1.25, it is having whole number as well as it is having fractional part. Since it is instructed to the computer that you have to take only integer. So what the computer will do? Computer will skip off this 0.25 and it will store only one value. It is going to store only one value. So when we perform here 5.5 divided by 4, we were getting only result as a 1. Result as a 1. So this 5 divided by 4 gives us a result as a 1. Next is what? The assignment operator. So assignment operator, what are we trying to perform? We are storing this 1 into the division. We are storing it into the division. We know that division is what? Division is a float number. Okay, division is a float number. Okay, float number means what? This division, I'm storing what? 1. Since it is a float number, this division is a float number, 1.000 it will update. Why 000? Okay, if you make this 1 and if you add after the decimal point, if you add any zeros, the value is not going to be changed. It remains same. This is been added because on the left hand side, the data type is what here? Float number. So we are getting, when we perform this division operation, we are getting 1.0000 value. This has happened. Why? Because on the RHS of the assignment operator, we have an division. Division here, it is operating upon integer divided by an integer value. When it happens, the resultant value what we get is again an integer only. That is the instruction or the we had given to the computer. Okay, then it is storing only 1, even though it produces 1.25, that 0.25 will be rejected or neglected by the computer and it will store only 1 in that one. Okay, and that one then we are storing into a variable. Since this variable is a float, so it adds automatically 0.0000 to make it look like a float number. So when we display it, when we execute the program, we get the output in this way. Okay, let me recompile the program and execute here. So we get 1.00. Understood this? So far, is it understood?
Yes, sir.
Yes, sir.
Now, someone had told me that when we do something like this, when we perform division is equals to float of 5 divided by 4, we get the actual result. This is one of the method of converting one data type to other data type. That is what we call it to be a typecasting. Before this one, let me explain you another simple trick here. Now, instead of this, what I can do here, 5 divided by 4 is there. Instead of writing this 5, I will write it to be a 5.0. I will write it to be 5.0 divided by 4. Okay, just pay attention here. I will just comment this line also. I don't require this as of now. So division is equals to 5.0 divided by 4 I am doing here. Now let us compile the program and check it. Compile, no errors, run the program. Okay, what are we getting here? Division is equals to 1.25. The change what we did here, the change is just a single digit we had added, that is fractional part. Instead of 5, I wrote here 5.0. Now let us try to understand what is happening here. Now tell me 5.0 is what type of data? Is it an integer or is it a I'm back again. So weird thing today. Okay. Am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
So,
Sir.
okay. So we were here. We did what? Division is equals to 5.0 and then divided by 4. Now here, if you look at the first number 5.0, what type of data type it is? Is it an integer or is it a float?
Float.
It is a
Float.
Float, sir.
Float.
Float, sir.
float, right? Why it is float? Because after decimal point, we had added a decimal point and then we have written a 0. 5.0, 5, both are same for us. But for the computer, both are not same. Okay, these two things will be identified differently by the computer. When we wrote only 5, it identified it as an integer. When we wrote it as a 5.0, it identified it as a float number. So this time it is a float number. Okay, now what about the second number, that is 4? Obviously this 4 is an integer number. Okay, now pay attention here. When I am what I am performing here, I am performing float divided by int. I am performing float divided by int. Now, if you look at the data types here, are these data types, both the data types are same or different? I'm performing a division operation, okay, but the numerator is a float data type, whereas the denominator is an integer data type. Definitely these two are not the same. Both are not the same. Then what compiler, it definitely is going to give us a result. Okay, when we perform the operation, it is going to provide us a result. That result should be stored as a float or it should be stored as an int. The question comes over here. Okay, numerator is a float, whereas the denominator is an integer, and I'm performing division operation here. So since both the numerator and denominator are both are of the different data types, then the resultant value in which format or in which particular data type I have to store, it should be a float or it should be a int. Okay, some doubt happens with respect to the computer. Right now, in order to avoid this doubt, we had again the compiler has been already instructed. If you face this problem, you have to use either of those two things, either it as a float or the int, whatever we have defined it to the computer, whatever we have instructed to the computer. Now tell me, what do you think, which one we would have told to computers to store, a float or a int? When we perform float divided by int, what we might have told computer to store the value, is it in the form of a float or is it in the form of an int?
Float.
Think float, sir.
Float. Okay, now you told it is a float. Now the next question is, why float? Why only float? Why not int? Why not int? To understand, or in order to answer to this one, we need the background of the data types. You remember the size of int was what? 2 bytes.
1.
Okay. 2 bytes.
2 bytes.
Size of int is 2 bytes. Size of float is 4 bytes. Is 4 bytes.
4 bytes.
Right? Now, think here. What I'm trying to do, I'm trying to divide a number. Numerator, I have 4 bytes, and a denominator, I have 2 bytes. Right? Float divided by int, it is, float means 4 bytes of value. I'm dividing it by a 2 bytes of a value. Means we have two things. On the top, we have a big number. On the denominator, we have a smaller number. This smaller and bigger is with respect to what? The number of bytes. Okay. Now, when I do that one, obviously resultant I have to store in a bigger value only. When I'm performing a 4 byte value divided by a 2 byte value, definitely there is a chance that the resultant value can also definitely will be what? 4 byte value only. So this I have to store the result in the 4 bytes value. So 4 bytes value is what here? It is a float. So we have instructed to the compiler that whenever you come across with these things where you are dividing a number or you are performing some operation where the one part is a float and other part is a int, what you need to do, you need to check the size of those variables, data types. It is a 4 byte, it is a 2 byte. Which one has the highest weightage? The 4 byte one. Since it is having a higher, that is 4 byte, then what should you do? You have to store the result in the higher size data type only. Higher size data type means what? Float only. Why this is happened? Because we don't want to lose any of the data. Don't want to lose any of data means what? When I perform 5.0 divided by 4, result is going to be what? Result is going to be 1.25. It is going to be 1.25. And it is been instructed you to store this resulting value as float only. If I don't tell, then what will happen? This 0.25 will be neglected or it will be omitted. The data will be lost. So we are trying to convert one data type to the another data type, right? We're trying to convert one data type to the other data type. Okay, this concept is called as typecasting. Converting one data type to the another data type is called as typecasting. Isn't it? Here what we had 5.0 and 4, two things, but the resultant is getting stored as what? Float value. So we had typecasted the values or the data type. And in the typecasting, there are
Sir.
approaches. Okay, let me finish up this one. You can ask the question. There are two types. One is we call it as implicit. We call it as a implicit. Okay, and second one is we call it as an explicit. Am I audible now?
Yes, sir.
Sir.
Okay.
Yes, sir.
So
Yes, sir.
we have converted one data type to the another data type. So that concept we call it to be what? Typecasting. So in the typecasting, there are two types. One is the implicit and other is explicit. Implicit means it is something like automatic. It is something called as an, yes.
Sir, myself, Siddharth.
Yes, Siddharth.
Sir, in the division part, if 5.0 we use it float and the 4 int. Sir, if we do vice versa.
I will come to that part. Okay, I will come to that part. Yes, you have asked a good question. I'm going to cover that part also. Okay. Now, as of now, just see here. Okay. Here we are trying to convert one data type to the another data type, and we call it to be a typecasting. Okay. And that typecasting, we have two types. One is the automatic and the manual. These are just automatic and manual is for your reference. You need to remember these two words, implicit and explicit. Implicit means automatically the compiler itself is converting. How? This is the example. It is converting explicitly. That is implicitly. The other one is something like this. If I write division is equals to float 5 divided by 4. Now here, if you look at numerator, I have an integer. Denominator also I have integer. But for the numerator, what I am telling, I in the sense the programmer is telling that you change this integer to float. You change integer to float. This is something I'm telling explicitly. Okay, you have to change mandatorily that this 5 to integer to float value. So this type of conversion is called as explicit conversion, explicit typecasting. Explicit in the sense the programmer will instruct in the code that you have to do, you have to change the one particular data type to the another particular data type. That is explicit. If we don't tell anything and the program, that is compiler itself, converts, then we call it to be a implicit conversion. Okay, good. Can you go on mute? Okay. Okay, appreciate you all students for connecting very quickly. Okay, so what we had discussed here, that we were trying to one data type, okay, to another data type. So that concept we called it to be a typecasting. Okay, so it happens in two ways. One is the implicit and other is the explicit. So in the implicit, what has happened? The example for implicit is this one, wherein we are not telling anything to computer or the compiler to convert it, but computer or the compiler intelligently it is converting one data type to another data type in order not to lose the data. Means it is not losing the data here, it is retaining all the data. So it is converting float divided by float into a float value and retaining all the result as 1.25. Other thing is that this one, we are explicitly means we are mandatorily, we are instructing the program that you have to convert this 5 into float. 5 is an integer, but you convert into a float. So that means what? Float divided by int is going to give a float value. Okay, this is how it happens. Okay, now you had asked one question in the previous line. The question was what? Let me comment these lines here. Okay, the question was, now what will happen if I write something division is equals to 5 divided by 4.0. Okay, we comment this also and this also. So this was the question. In the previous time, the numerator value we had done the 5.0 and denominator we kept it as an integer. This time we are reversing it. The numerator part we had kept it as an integer value, and the denominator part we had made it as a fractional value, that is float value. Then what will happen here? So what are we trying to perform here? If you understand, we are trying to perform integer divided by a float. Integer divided by a float. Then what do you expect? Will the result stored in an integer or float? Who can answer?
Float.
Okay, if you look at here, what has happened?
Float, sir.
Divide integer divided by a float. Now integer means what? It is 2 bytes of data. It is 2 bytes of data. And we are dividing it what? We are dividing by 4 bytes of data. Now between this one, which one has got the highest size, the more size? It is float. Okay, for that purpose, we are storing, the compiler itself is automatically converting the data type, the result, into a float data type. Okay, so is that understood? The implicit and explicit, this is nothing but implicit and explicit is nothing but it is the type of typecasting where one data type is converted into another data type. Okay, is that understood, student? Today's class was a very tough class. We had a lot of disturbances, internet connectivity issues. Am I audible now?
Yes,
Audible, sir, but cracking.
Why is it cracking, sir?
Yeah, I don't know what has happened today. The internet is not good. Okay, it is showing the strength is okay. Fine. So is that understood now? The typecasting, the overall concept of a typecasting means what? Converting one data type to the another data type. Okay, two types, implicit and explicit. In implicit, the compiler itself converts one data type into the another data type, whereas in the explicit, the programmer will insist the code or the compiler to convert it by writing the corresponding data type over here. When I write a float within the bracket, that means you convert one data type to the another data type. Okay, this was the one example of typecasting.